For this portion of the review, I'm going to show you how to work the problems on the first page. The top part should all be gotten from your notes. So the problems really do start with number 6. So read over question 6. First thing you should notice is that word resultant. When you see the word resultant, it means that you will be adding forces together. So we see 3 forces, and that might surprise you, but if you draw them out, let's see what we get. "31 newtons pointing north, "26 newtons pointing north, and 14 newtons pointing south." So you only see 2 directions. First, let's combine the like directions. Because 26 plus 31 equals 57, we have a 57 newton arrow pointing north and a 14 newton arrow pointing south. So by combining these vectors, we add them together, but remember, the 14 goes the opposite direction, so we make it a negative. 57 minus 14, you end up with an answer of 43 newtons. We have to think about the direction next. We went straight up, we came back down south, so our primary direction is north. There is no angle, it is not a triangle, so our direction is 43 newtons due north. We started here, we ended here. We ended up to the north of our origin. If we wanted to call that something, we could call it F net. Now in number 7, they want to know the equilibrium for number 6. Well, the answer to number 6 was 43 newtons due north. The word equilibrium means same size or magnitude, but opposite direction. The magnitude is 43 newtons. The direction was north. We will switch that to be opposite. Due south. Okay. Problem 8. Now we're going to make things a little trickier by having a right angle. 2 forces act on an object, 470 newtons east I already know that I'm talking about a triangle problem because it said 2 forces acting, but the other reason is they've asked for resultant and equilibrant. Those are my clues that I'm working a triangle or Pythagorean theorem problem. 470 newtons to the east, 630 newtons to the south. My resultant vector is the hypotenuse, so that is my C. Triangle questions will be answered using the Pythagorean theorem. A squared plus B squared equals C squared. So at this point, you should be able to fill this in. A, 470, plus B, 630, don't forget to square, is going to equal C squared. I always like to write everything down So I'm going to square 470, add 630 squared. I get a pretty large number for c squared. 617,800. Remember not to leave it like that. That's c squared. I have to take the square root of that number, and I get 786, and I can round it off right there. Do I have units? Yes, I do. This is a force, so it's newtons. I'm not finished. The next part of any triangle problem is to find the angle. Remember that our formula for this, inverse tangent of the small over the big. Our small side, if we look at our picture, is 470. Our large side, 630. Now, depending on how your calculator works, you should know how to do this part. My calculator, I have to put in the fraction first, and I get 0.746. And with my calculator, I can immediately press the inverse tangent button, and I end up with an angle of 36.7. I'm going to round that up to 37 degrees. You could have left it at 36.7. That would be absolutely fine. Now, that's not the end of the question. I have to put these together as a resultant and an equilibrant. My resultant starts out with my force, 786 newtons, then my angle, 37 degrees, followed by my direction. I look again at my drawing and I say small direction of big direction, east of south. The equilibrant is very simple. All that I need to do is take the exact same magnitude, exact same angle, and make my directions opposite. The opposite of east is west. The opposite of south is north. Okay, that's the basics for solving an equilibrant problem. So I want you to try to work number 9 on your own. You should pause, start the problem. If you get stuck, then you should unpause. Watch the next steps, make sure that you're doing it correctly, and then when you feel comfortable, pause again and move on. I'll begin working the problem for those of you who need help setting up. What I look for first in my problem are the numbers. I automatically see directions. I haven't even read the question yet. But if I skim through the question, I'll start to see equilibrant, resultant. I see this too, constant velocity. Okay, so there's a few things going on here. But I believe by looking at the question and reading that last sentence, resultant force acting on the furniture, what equilibrant force will keep it moving at a constant velocity? Well, I'm talking about a net force of 0. I don't have a coefficient of friction. They don't describe friction. So really, all that I'm looking for is that same thing we had before, resultant and equilibrant. Again, I start with my picture. Technically, you are supposed to draw the big first. I forgot that last time. It doesn't change your answer as long as you're always doing small of big. Let me move that over a little so you can see. My big vector is 335 north. My small vector is 250 to the west. So my resultant will be heading this direction. Again, I solve with the Pythagorean theorem. If you feel caught up at this point, pause it, work through your Pythagorean theorem, and check back to see that you've set it up and done it correctly. So I can round this one off, 418 newtons for the magnitude of my force. Now I need to find the angle of my force. Coincidentally, I get the same angle that I had before, 37 degrees. I put this together, my resultant, my directions, small of big. I can't see my picture. There we go. Small, west of big, north. I don't need my picture anymore. I can flip these. And that's the first page of your review.